dookie. First, I want to give you some problems, I think. This one?
Yeah.
It's possible. I want to talk about it still for just a second, though. But let me give you some homework to work on.
God darn it! I was hoping you would find it. Is it a lot?
Hmm? I don't know. It's 7 problems. Is that a lot? Is that? This is from the handout I gave you last time. I don't know when you want to do.
When we have the test.
That's probably a little long.
Don't give us the homework. A week?
A week, Wednesday? Is that okay with that?
Is that ready to shoot me? Is that what? I would. Pew pew!
He's Buzz Lightyear. He walks around. I'm Buzz.
So I was going to say that Haley's clearly been around a lot of weaponry. That's what all guns sound like.
Yep.
Yeah, that boom stuff, that's just Hollywood.
There you go, Marshall.
Well, I was doing good till I saw board.
I don't know why he would say that, but that's just what I expected to come next.
It was fun till I saw you.
I meant the homework, Dr. Joe. It's always good to see you.
Oh, thanks, Marshall. Does everybody have the handout I gave out last time?
No.
Yeah.
Yeah. This, yeah.
Yeah.
4.6.
Yeah? Okay, good. I'm glad that was a yes because I'm not sure where they are right now in my pile of stuff. It should be on the back side of 4.6. Right?
Yeah. 4.6, 4.10, 4.10.
You asked me to cover 3 to 4.
Because the 4.6 and the 4.10 are problems that the manual writer wrote, and they're, I think, a little bit more straightforward than the sample exam problems that pop up. So that was why I did it in that order.
Wait, what?
Why I copied it as 4.6, 4.10, and 4.8. The person who wrote the exam manual that I took the problems from writes problems that are more straightforward to illustrate the ideas than the sample exam problems that are in there. The sample exam problems are in between the basic review problems and some of the lecture problems. That was why I copied it that way.
I gotta do it 4.6, 4.8, 4.10, otherwise it's gonna.
You can do it.
I definitely wrote it down that way too.
You can absolutely do it however you want. I'm just telling you where the problems are located in your packet. Where you put them in, I could not care less.
Okay, good, because more probability when we start order.
Well, that's
Do them
unacceptable.
on sticky notes.
What's that?
I started doing them on sticky notes and just staple the sticky notes together.
Honestly, he probably would give you crap, but he wouldn't care.
Yeah.
Individual note cards.
Individual note cards, sure. That works. All right. So I know that we talked about this particular problem last time, but I wanted to go back and review one of the formulas that we came up with. Remember that we said that our first principle said that the price of the bond was our redemption value, the present value of the redemption plus the present value of the coupon payments, right? But then we played around with the formula and said that if the redemption value and the par value are the same, then we can also do the price as the face value all by itself plus the present value of the difference between coupon payment and interest payment. That was the second formula we came up with, right? We agree? Okay. So when we're talking about doing these interest portions and principal portions or amount of premium or amount of discount in the coupon payment, we're talking about essentially amortizing this piece of the bond price. Because it's this piece that represents the premium or the discount, right? This is its face value. The amount of premium or the amount of discount is this computation on the right. Now, I didn't get to talk about that much last time, right? But that's what this part is. This part represents the amount of discount or the amount of premium. So when we're talking about amortizing those pieces, that we're really talking about amortizing that just like we did for loans. So if you want a principal portion or premium or discount portion or interest portion of a coupon, you can use those same formulas that we used back for loans, where this is your regular payment, the F times R minus I. So if you want the amount of premium or discount, depending on what you're looking at, in the teeth coupon, that sounded funny. Teeth, yep. You would do your F times R minus I, because that's your payment, times V to the N minus T plus 1. It's the same formula. It's just using that F times R minus I piece. And then you can do your interest by either subtracting it from the entire coupon or using the other formula. So it's fairly straightforward to compute it directly. Notice that if your coupon rate is less than the yield rate, so what that means is the bond gives you less of a return than what the market says you should be getting for a return. The bond would be sold as a discount, and this value would be negative. So you're doing that negative amortization in that case, right? We can see that if the coupon rate's less than the interest rate, that's negative, right? So what that means is that each coupon payment has a discount associated with it, so the actual interest in that coupon is greater than what the coupon is. Because you got a negative amount of discount that has to be amortized over the years or over the payment periods. And again, we're not going to worry about that in particular, besides being able to compute it, but that does pop up for tax purposes. It's the whole point of doing this. Because what you're interested in, pardon me, what you're interested in is how much interest income did you earn? Because that's what has to go on income statements and on tax statements, and tax returns, and those kinds of things. So you're going to be interested in amortizing this piece. Now again, if you paid a premium, if the coupon rate's bigger than what the market rate interest is, then each coupon has a premium part back, and you're not going to be making as much interest income because you paid extra to get that interest back. So you wouldn't have to pay as much taxes on the interest for the whole coupon because part of it's not interest. Part of it's just getting your money back that you paid extra to get that interest. Does that make sense, what I'm saying? Most of it's for tax purposes. Which, if you've ever seen any tax law, you know those things are complicated as all get out. But that's the idea. All right. See if we can do this one here. These are the first two problems that are on your packet for the back side of the first page. Hello, how are you? Good? You're welcome. All right, so if I wanted to do the first one, what would I do?
I might have to. Sounds like a good idea.
What's that?
Double fisting calculators again today.
Oh yeah, that's an awesome idea.
N equals 30.
Okay, so why is n equal to 30?
Semi-annual.
Okay, good. Semi-annually for 15 years, right? So we know the n's going to be 30. What else? Say it again. Is what?
Par value.
The par value will be your future value, because that's what you're going to get back, and what your coupons are being based on in this case. So the 1,000 will be your future value. What else do we know?
$30 would be your.
35.
Is it 30 or 35?
I don't know which one.
Yeah, it's the 35, right?
Wrong one, I'm sorry.
What's that?
Seven.
Oh, yeah. So the coupons is what your payments are. Semi-annual coupons, these are going to divide the interest rate in half to 3.5 times 1,000 gives us a 35. We want the redemption value, the future value, and the payment values to be the same sign because you're getting those back, right? You'll be getting the coupon payments plus the final redemption value at the end. And what else do we know?
I is,
It's 0.03, so we'll type in 3 for the I/Y, right? And then what do we want to compute? Oops. Probably the present value. Compute present value. We get 1,098. So does that mean that the bond was sold at a premium or sold at a discount? The premium, right? Because it's higher than what the redemption value is.
If they're equal to each other.
Then it's called sold at par. And sometimes you'll see a problem where it actually says that the bond is sold at par, which means that the price is the same as the redemption value. Which means also that your coupon rate and your yield rate are the same.
Why would you do that?
Why would you do what?
Why would you buy something?
Well, it depends on the bond. A lot of times the bonds are considered more safe, are safer investments than other ones, especially if you buy them from municipalities, because the chances that your government would default on your bond is not exceptionally high. So if you had those were at the prevailing market rate that you get somewhere else, then you would do that.
What happens if it does?
If the bonds are default, then you're just out the investment.
So you don't get any.
You don't get any money back. So well, I mean, there have certainly been colleges and universities that have gone bankrupt, gone under, closed the doors. So say they had bonds out because they did capital projects, and so people invested in the capital projects and said, okay, we'll invest money, but we expect interest payments back. And before those bonds were paid off, the school just went under. Well, then the people are just out the money.
So it's just tough luck.
It's just tough luck, yeah. Just like any other investment, if it goes south, it's just tough luck. I know, not so good, is it? All right. So this one is sold at a premium, so you could be asked things like find the amount of premium in the 13th coupon. And again, if we have the calculator, that's fairly easy, right? Because we do that just like we do for amortization. We would go to second amortization. If I said for the 13th coupon, I would just, change P1 and P2 to 13. And then it tells me that here's what the balance is on the bond. What that means is that, say you already got 13 coupon payments. This is how much the bond is worth right now. So if you wanted to sell it, this is how much you could sell it for under the same conditions. Okay. Does that make sense? And then if we scroll down again, I should be able to find the amount of premium There's the amount of premium that was amortized in that 13th coupon. Not a lot, about $3. And then the rest was interest, $32.
So if it was a discount, would that principal be negative?
That principal would be negative, and we'll see that when we do the second problem part. So I'll go back in there again and see where we'll have a negative. And then your interest will actually be more than what the coupon payment is, because the premium that was amortized was negative.
Okay, so our answer to your question would be 2.94.
Correct. The answer to my question would be 2.94. Yeah, Marco?
Why did we use the 13th coupon again?
Oh, I just made it up. I just wanted to show where it was, and again, just to remind that it was under there. There was nothing on there that said it should have been the 13th. I was just making it up. Yeah. Great.
So if we plug this into the f times the r minus I and d to the n minus t plus 1, we'd get
Yeah, you should get the same answer. Yeah, exactly. So if you take the F is 1,000, so R minus I, so both those are, that would be the semi-annual rates. So your R would be 0.035 and your I would be 0.03. So you would do 0.005 of 1,000. So that's what, 5? Right? And then your N is 30 and your T in that case would be 13. So you would have 18. So you do V to the 18th. So you do 1.03, flip it to the 18th, and then multiply it by 5. I should get the same number. So it's exactly the same idea. So that would be just using the formula. And you do have to remember with the R and the I, of course, you have to change the decimals of that. And make sure that you're on the right period. So those were semi-annual rates. So my R would be 3.5%, and my I would be 3%. Yeah. Okay. I'm good at that. I'm good at never minding. What would I do for the second part?
Put in 975 for the present value.
Okay, put in the 975. Do I want to do anything to it? Make it negative. Good. Put it in for the present value.
Calculate I over Y.
Good. Calculate the I over Y. And then multiply it by 2 to give the nominal rate. Good. So 7.27% in that case. Does that interest rate make sense?
Yes.
Well, let's think about why. You're exactly right. Why does that interest rate make sense? Is this bond being sold at a premium or a discount for the second problem? It's at a discount, right? If it's at a discount, that tells you that the market rate is higher than the coupon rate. Because again, think about why that has to be true. If the market rate is higher than the coupon rate, you could get a better deal by putting your investment somewhere else than getting the bond. Right? So you should pay less to get that bond than the $1,000. You'd be better off putting your $1,000 somewhere else. Does that make sense? That's why it's cheaper. Okay. So then again, in this case, if we go to the amortization table, and I'll just leave it at 13 because I had it at 13 before. Here's the balance. Notice in this case, the balance goes up, right? And that makes sense. It's still at a discount, but it's not as long as it was, right? You agree? There's not as many coupon payments to get back. So you're not going to get as much of a discount. And then like Grace mentioned before, you're going to get a negative premium, or excuse me, negative amount of principal, a negative amortization here. You're amortizing your discount, and then your interest is actually more than the coupon payment in this case. That good? Everybody's quiet. Come back for probability, it won't be quiet.
No.
All right, questions on that one? Oops. All right, let's look at the next one here that I have, 4.8, number 10. It has a slightly different concept that I haven't mentioned yet. And that's the idea of the zero coupon bond. All that means is It's a lump sum. It's like you're gonna go take and make a deposit somewhere, leave it, and then get money back at the end. That's what zero coupon bond is. All right, so what do you think we need to do?
Would the interest for the zero coupon just be faster than the 64?
Say it again.
The interest for the zero coupon bond,
Okay,
would it just be 1,000 minus 624?
that's the amount of interest, yeah. Well, we need to know that to get what it's asking. What is it asking?
That's what I mean, like, minus that equals to the other thing.
So let's find the interest.
Okay, so what are we looking for? What's the problem that actually asking us for? What's X representing?
Present value.
It's the price of the bond, right? Right? The X is representing the price of the bond. What do we need to know for price of the bond? I need to know the future value. I need to know the payment. I need to know the interest rate and the time, right? Well, I certainly know the coupon rate and the future value, the par value, right? So I know payment and I know future value. I know time, but what don't I know? I don't know the interest rate, right? That's the piece that's missing that I don't know from this. How am I going to get the interest rate?
Equal to each other and solve that.
Okay, yeah, I need to use the first sentence to figure out what the interest rate is, right? How am I going to figure out from the first sentence? What do I need to set up to get that?
24 times 1.
Okay. Okay. That's a 1 plus. The pen's being really sensitive. I'm not even touching the screen when I'm doing this. Is making those lines. It's being really sensitive, which is why it's being a pain. Yeah. I don't know why it's doing that.
That just says 24.6.
Yes, it is.
No, I really could not tell. I really could not. I just want to double check.
No, I don't blame you.
At least I wasn't as aggressive as Michael usually is.
Yeah. Let's not talk about that.
You dread him coming.
No, I'm just still a little irritated by Monday. So,
What happened Monday?
from class on Monday.
What happened on class Monday? I wasn't there.
Oh yeah, remember, why is this important?
Oh, that irritated you?
Chris, what does it irritate you?
Well, we're going to have a discussion about it at the beginning of class, so what do you think?
He asked why probability was important?
That's why what I was doing specifically was important.
What were you doing?
Talking about least squares. No, and I would have to be deriving the formulas in the middle of it. And then after I get through and talk about what was important, I was still told it wasn't important.
Are we just gonna use the board?
I might be still seething about it, just dead. Is that fine? We should say Grace, I didn't hear what you
Is
said.
that, so we're just, you didn't do it yet?
I haven't done anything yet, nope.
Hey, Dr. Joe.
Yeah.
I think the stop sign has a better use.
I think you're right. All right, so I need to use this formula to figure out what the I is, correct? But what time period is this I going to be based on? That'll be an annual one that we do, right? So before we put it in the calculator for the price, I'm going to have to convert it to a semi-annual rate, right? As a matter of fact, it might make more sense to do what?
1 plus I squared over 2 to the 24th.
Yeah, it might be easier to take this to the 24th and just find the semi-annual rate to start with. The only reason why I say that is because I need a semi-annual rate to plug in for the second part, right? And again, the reason for that is because it's telling us that we have semi-annual coupons. So there's nothing wrong with making that to the 12th power and figuring out your I, but then you're going to have to convert it to a semi-annual rate anyway. So you might as well just do it from the start. So if I do this in the calculator, let's clear this out. Oops. So the 1,000 is the future value. The 624.60 negative will be the present value. And I want 24 periods. And I want to compute the interest rate. Anybody else get 1.98 for the interest? Cool, good. So I just use the time value money for that. The reason why I use the time value money for this is now it's already stored in here, so I don't have to retype it in again. So now I just need to do the rest. And what's the number of...
We did PV, FV, and what was the last one we did?
Oh, I'll do it. Sorry. Did I do it too fast?
Yeah.
Sorry. Clear it out. All right. Maybe I'll clear it. Second, clear. There we go. Put 1,000 in for future value. And then 624.60 negative for the present value. 24 for N. And then compute the interest rate. And we don't need to put anything in for the payment because there is, in this case, the zero coupon bond, so there's no payments. Okay. And now that I have it in the calculator, now I don't need to change it, right? It's already stored in I/Y after we compute it. What else do we need to change now? What do we need to put in for N?
20.
The 20. Right? What else do we need to put in? Payment of 30, because they're semi-annual coupons in this case. Future value was, we already put in 1,000, didn't we?
Yeah.
So I don't need to change it. So let's compute present value. And we got 1167.
Yeah.
Which is one of the answers. It's always a good thing, right?
So we were looking for the present value.
Yeah, we were looking for present value. We were looking for the price. Yep. That's okay? For the most part. Any questions on that one? We're also happy. At least you didn't ask me why it was important.
It didn't really last that long.
It was about, what, 5 minutes worth of getting questions?
It was a good portion of
Yeah.
that.
Yeah.
It was.
I mean, I was very focused on my coloring, so like it
Yeah.
seemed like it went by much faster.
Mhm.
But it was,
Yeah, it was on the recording.
It was a little out of control.
Yeah, Sam?
Are we going to have to use net present value for any of these?
No, not for these. All right, so this one, I put this one on here because you have to go back to first principles to do this one, but you can still use your calculator to find it. But notice it says calculate the redemption value, right? So in this case, we would want to calculate the future value, right? What's wrong?
I made a comment about the fact that you put labels on it, and it looks nice and neat now instead of untitled.
Untitled.
4.10, untitled.
Sorry. Well, you harassed me enough into doing it. It's a good idea.
It's nice and neat now.
It is nice and neat. I agree. So if you're doing this on the calculator, it shouldn't be too bad to plug in. Tell me what you would plug into different pieces on the calculator here.
Calculator?
It's 20.
100 should be.
Okay, the 100 should be your future value.
20 is your
I'll be
N.
quiet.
20 is your N. Why would you be quiet?
18.2 is your
Haley is yelling at me.
I
What?
didn't yell at you. I just said way to take credit for my answer.
No. The 118.2 would be your. Oh, wait a minute. No, 100 is not the future value. Sorry.
I is 3.
I got it wrong.
I also got-
I is 3. Why is it making so dragging across things? I don't know why I started writing these. And the payment's 4. And you're going to compute the future value. Yep.
How do you clear the future value?
I would just clear future. Yeah, I would just clear time value money and just start over again.
What did you guys get?
I didn't do it yet.
I didn't clear it, and I still got 106.
Because you changed every other number, right? You changed every other single value before you computed, so that's the same.
Why is the par value the future value and the other problems come out this way?
Yeah.
Because in most problems, it'll be what they call redeemed at par, but they don't have to be. The par, technically speaking for bonds, the par value is what the coupon is computed on. It's what's on the face, exactly. So also the face value. And that's technically what the par value is. It's not, it typically is, but it does not have to be the redemption value. The redemption is just the amount that you're going to get back at the end. So sometimes it's higher, like it is here.
Oh, because we're calculating it too.
Because we're calculating, yeah. Yep. If it doesn't tell you, then you're supposed to assume that it's a par value bond. It's a redeemable at par, I should say. But that's why. Every other problem didn't tell us, so we just assumed that it's the same. That good? That one was not bad, right?
No, not too bad.
Not too bad.
These are very heavy.
Yes, they are. Oh, yeah. These are very, very heavy. Haley's always mean, though.
Dr. Joe Grace deserves it. I'm just trying to get us to do more work.
She always likes to do more work.
I didn't suggest that we should do it on paper. I was simply making an observation.
Yes, those observations can easily be interpreted as suggestions that you want.
No, that's too soon.
You assume. All right. So let's think about this particular problem, reinvestment problem. So this person is taking a bond and getting coupon payments, and instead of keeping it and putting it in his or her wallet, taking it and putting it in the bank. So it is a his. Okay, so let's think about what's going on with this problem before we make groans. Okay.
My was because I was confused.
Okay.
It wasn't a groan.
How much is this person investing?
$1,000.
The interest rate. So
No, present.
Okay, how much is the person? The 925, right? So the person's only investing 925. Is the person getting anything back in the middle? No.
Why not?
Because it says it's taking the coupons and sticking them back in the bank.
Oh, okay.
Right? So basically we can treat this like it's a lump sum to figure out what the annual yield's going to be. They're going to put some money in at the beginning and get some money out at the end. So we just need to figure out how much money they're going to get out at the end, so we know how much money to put in at the beginning. Right?
And then do we add 1,000 to that? Or like
Yes, we need to make sure. That's exactly what I was going to point out. Whatever we get for those payments for future value, we need to add 1,000 to it so we know we get back at the end. Okay? All right, so the first thing we need to do is what? Find the future value of the coupon payments, right?
yeah,
Right? That part?
we're doing the annuity for that, right?
Yep.
So that would be, what charge is this? 4.8, 14.
Yep. All right, so how much is this person putting in the bank each time?
45.
45? How'd you come up with the 45?
9 divided by 2. So,
Good.
yeah, the
4
9% divided by 2 times 1,000.
Good. 4.5% is 1,000, so it's 45. How many payments are going in the bank? 20. At what interest rate are those payments being invested at?
Wait, what was one?
7%. No.
It's 3.5.
Yeah, the 3.5%. And we want to compute what again? Yeah, the future value, right? Good. So that's the amount that the coupon payments grow to. 1,272 and whatever change. Is that what others got?
Yeah.
All right. So let me store this so I don't lose it. I want to clear out my time value of money again, which is why I make sure I store it so I didn't lose it. I didn't need to, but I just wanted to make sure I did. This is how much the coupon payments are worth at the end, but is that the only thing the person gets back? Plus 1,000. Maybe. There we go. Oops. I told you I was going to lose it. There we go. So I added 1,000. Where does that need to go?
You have to
Future value, good. That's how much I get it back at the end. What is the present value? 925, right? Remember, this is just like a straightforward lump sum investment. At the very, very end, the person's going to get 2,200 whatever. At the beginning, they put in 925, right? 925, maybe. Negative. Present value. Present value. I'm trying to figure out the interest rate. It wants annual yield in this case. What am I going to put in for 10?
For what?
10.
Yeah, probably 10 since that's what I said. And then we want to compute what? I. Good. We're going to get 9.4.
Nope.
What did you get?
12.8.
Did you clear your time value?
And make sure you clear your time value of money. Or it could be what every time I would do these problems, is I would do the problem, and I would get it wrong. I would do exactly the same thing, and then I would get it right.
It's like
Marshall.
So when it says is nominal annual yield rate convertible semi-annually, do we not need to take that interest rate divided by?
Oh, I didn't read that. Sorry, I just read annual yield rate. Nope. I should have used 20 for the end.
Oh, okay.
I should have used 20 for the end and then multiply by 2.
Wait, so we gotta do it all over?
I messed up. I just need to change this to 20 and compute I/y and then multiply by 2. So it should be 9.2. My bad. I screwed up. Thank you, Marshall.
Dr. Joe, you failed my FML.
I did fail.
Wait, so.
It's the FML exam?
If I'm trying to get that.
Why did I
Those are
I was trying to think of what I was like, what would L stand for?
really?
Oh.
Oh.
Dr. Joe,
Yes.
what is the difference between the financial mathematics exam and the mathematical finance exam?
That has more on it. The second one. The second one that you mentioned has more on it. It does. The mathematical finance exam, so what is it, something financial markets, I can't remember what the I stands for.
International.
I think it's institutional, if I remember correctly. But it doesn't matter. It has options pricing, more stock valuation, those kind of things. So more of a financial instruments idea, where this is the more basic underpinnings of those things.
Is that one basic?
Yes.
Is it harder than P?
I don't think the content's harder than P. I think there's, again, just more stuff. There's new stuff in there. There's doing some probabilistic modeling of things.
Are you taking that one?
I have not. That's why I want some people to take the class so that.
Grace, we're taking that class next year. You, me, and Dr. Joe can all go take the test at the same time.
I don't know what class you're talking about, but okay.
Yes, Grace.
So, to get that number, I got my future value. Do I still want the payment?
Nope, no, 0 should be a payment. Yeah, and then 925 negative should be your present value. Okay, 189 should be Did you put 925 negative and then like that?
Wait,
part of
was
that
it-
divided by
The
5?
answer was 9.2?
Yes.
That's what I got the first time.
Yeah, you were right. Marshall corrected me and I messed up.
What do we need to change?
We need to change N to 20 because it's asking for the convertible semi-annual rate. I just did the annual rate. I did the effective rate.
Dr. Joe, I give up, I can't do it.
Marshall was right.
Oh, my question was
You
wrong,
might
I
have
just led you to
bookmark
right
this on your
Yes.
Why do we
Yeah.
have to add the 1,000?
Because you get back what you invested with the coupon payments, plus you get back the $1,000 at the end.
I thought each time we were reinvesting the.
You're reinvesting the coupons, but you still, at the very, very end, at the end of the bond, you get the last coupon payment plus $1,000. The $1,000 comes back too. That's why.
I just remember it being-
Alright.
Dr. Joe, I got it wrong.
Oh,
Do I have to multiply it by 2?
Say that again?
Do I have to multiply it by 2?
My class was just way too
So I got like 4.59.
There we go.
Yeah, you multiply.
You multiply by 2, yes.
Okay.
All right, let's do this one. There's going to be one more concept we're going to have to do on Monday because we're not going to get into it today. And that's the clean price and the dirty price.
How does the callable work? We actually do anything?
Yep, we do. And well, we just need to think about it, what makes sense, and then we'll understand why. Okay. Balloon payments, those are loans. Those are just, balloon payments or drop payments just mean your final payment's larger than your level payment was, and drop payment means your final payment was less than. Literally, that's the only thing those two words mean. Balloon and drop, yep. Okay, so I want to talk about what the callable means. And all you have to do is just think about what it means to figure out how you're going to price it. That's all we want to talk about. So it's not a hard concept if you actually just think about what's going on. All right, so the callable part means that the person who is issuing the bond, the person who is making the coupon payments, might want to get out of making the extra coupon payments at the end. They want to pay it off early, right? For whatever financial reason, they don't want to pay it off early. They're just sick of paying interest payments, okay? So this one says that after 7 years, so after the 14th coupon, whoever issued the bond can just pay it back, just issue the redemption value back and call it good. And then no more coupon payments will be made. Okay? So it's entirely possible for the investor to only get 14 coupon payments rather than 20. Does that make sense?
Is it 14 for any particular reason or just?
Because it says after 7 years. And it's
Oh,
semi-annual.
you're just saying less.
Yeah. So the investor will be guaranteed 14, might get 20, but doesn't have to. Because essentially the issuer of the bond has an option, and that's what one of the things you talk about in the mathematical finance class is options, but has an option to say, I'm done paying this, okay? I want to pay you back the redemption, we're good, we're square. All right. So think about it now from the investor's point of view. In particular, let's think about if you're buying at a premium. If you buy this at a premium, which in this case we would be buying, correct? Because it has higher coupon rate than market rate. So this would be a premium one. What happens to the price the longer the period gets if you're buying at a premium? What happens to the price the longer the term gets? If you're buying at a premium, what happens to the price? Or if you're buying at a premium, what happens to the price? It's high. It gets higher and higher and higher depending on the term, right? So, if you're an investor, would you want to pay the 10-year price for this bond, knowing that it could just go away in 7? No. If it's going to be higher the longer the term is, do you want to pay the 10-year price? No. What would you want to pay instead? The 7-year price, right? Because it could be called after 7 years. You don't want to get screwed out of money if you're paying a premium, right? So if you have a callable bond, and it's being sold at a premium, you're going to use the call term to price it. Okay? You're going to use the shorter term. And again, the idea is because for a premium bond, the price gets higher the longer the term is, right? You want to pay as little as possible, so you're going to use the call term to price it. Does that make sense? Now let's think about it the other way around. If you buy a bond at a discount, what happens to the price as the term gets longer? It goes down, right? The longer the term, the lower the price. Okay? So if you've got a callable bond in that case, and as an investor again, you want to pay as little as possible, are you going to use the shorter call term or the longer bond term to price your bond? The longer bond term. Good, exactly. All right, so for callable bonds, that's the whole point. That's literally the only thing that's different. Okay? For a callable bond, oops. Premium, you're going to use the call term or the shorter term to price. Discount, you use the full term to price it. That's literally the only difference between the two. Okay?
That's it.
That's it. You're going to price it exactly the same way that you priced it before. Okay? Same concept, it's just whether you're going to plug in for N. The only thing that changes. So in this problem, you ordinarily would have put in 20 for N, but since it's being sold at a premium, you'll put in 14 for N. And if you're ever confused and don't remember what you're supposed to do them both and use the lower price. Because the investor is going to pay the lower price. So if you're going to, if you're confused, you forget, flustered, what have you, do them both and pick the lower. Because if an investor is always going to pay a lower price for the yield that they can get. Know what you guys do? Yeah. Okay, cool. All right, so I still need to talk about pricing bonds between market rate dates, but we can do that on Monday, so that's not a big deal. And then we'll get into the next chapter, which talks about duration. And duration basically is an average idea. It's how long on average you can expect to get your investment back, essentially. Okay. So we'll talk about that, start talking about that on Monday. We'll actually do a little bit of calculus too. I should take a derivative. Oh my goodness.
We're Gary.
Like a Calc 1 derivative?
Not like a Calc 1 derivative.
Okay, alright, that's good.
Partial derivatives at all?
Not for us, but there will be in the next. I mean, if we do mathematical finance, there's some partial derivative stuff in there. Doing different pricing things. I don't remember off the top of my head because it's been a while since I thought about it. But yep. All right. Have a good one. Remember, no class Friday because I'm not going to be here. So I'll see you Monday.
Dr. Jones, there's issue 5.
It always has an issue.
You don't have enough McCafe web protections.
Probably not.
I don't know, I don't like to look that far ahead.
Kelly, I think you came in after I gave out the homework.
I like to focus on the present.
Let's see if I can get back to it. Sorry, I forgot.
Thinking about how balance.
There it is. Up in the upper right. Whoops, it was in the upper right hand corner. Sorry about that. There you go.
When is it due?
Wednesday. All right.
Here?
Yep.
Okay. working. Dr. Joe, I really struggled with this homework last night.
On the probability homework?
Yep.
I'm sorry.
It was late and I was like, I have no clue how to find the probability that x over 2 is less than or equal to y, which is less than or equal to x. I couldn't figure it out. But then I figured it out.
Then you figured it out?
Hey, hey.
I was gonna.
Oh. I thought you were showing me something.
Dr. Joe,
Yes.
trick question, what century is it?
What century is it? I don't know. Where are you counting? Where are you counting from? Megan, for some reason I did not give you your homework back last time.
But still, so.
That's Monday. When is the 17th, 18th? 18th. Right, it's Tuesday,
I'm
19th.
gonna start the pile.
You're gonna start the file? Wonderful.
Wait, was that the?
No, that was not.
I started the pile then.
I'm doing my best to try to reserve a room. I don't know what room yet, because the stupid reserve thing won't work, but that's what I'm gonna do.
Gotcha. Thank you. Thank you.
I'm sorry.
Oh, it's fine.
I always forget to say what.
To staple my thing.
I know we talked about previously that I could take my exams on Mondays if we have it on Tuesday. Is that still okay? For
Yeah,
this
it's okay.
week?
Yep. Katie, were you thinking about a specific time on Monday?
Just after this class.
Just after class? Okay.
That's okay.
Yeah, it's fine. It
We
works.
basically have from 2 to 6 open, so just be.
Gotcha. No, that's fine. Yep, that works for me.
Thank you.
Yep. Thank you. Uh-huh.
Yeah, I'm gonna fight for it. I still have to find it.
Nice.
I got it.
Woo!
Yeah. Well, mine's not running.
I guess that ever works.
Yeah. You see one?
Are we doing problems or are we learning?
We're learning and doing problems.
I like to do problems.
Always learning.
I'm not starting. I need to start.
What?
There we go. Anybody else feel like they're dying a little bit?
Yeah, I'm really tired.
We're all college. I'm just asking about dying.
I'm feeling pretty
We're all
good.
college. Just asking about when we're dying.
Thank you.
I'm alright. Yeah, I'm alright. I get used to a little bite to eat, but yeah. A little snack. Dude, I've got to finish number one still. I cannot figure. This is the hardest test he's ever given us. It's not. It's I just got to finish part 2, and then I've got to start C. Yeah, I was looking for formulas for the radius, but I don't know. It's like every time I sit down to do it, I just don't want to do it anymore.
She thinks you're giving us homework.
I am.
Son of a bitch.
Homework? Be nice.
I wasn't being vegan.
Oh yeah, I see. Yeah.
Okay, Michael.
Yeah, we talked about in the book if you
You still wouldn't be able to take the back. It's like Michael.
That'll be funny.
a full circular orbit is radius ability, and then you lose out to a and whatever the averaging of that orbit
When you take your test?
another
Did you Did you do whoa?
Do you think I'm like quick at homework?
Michael, it's not that many problems.
That's a lot.
Just
Really?
yeah.
It's very below average.
It's true.
Is 4.3 in the book?
Yes.
How many parts are in?
We never did stop the last one.